Hello, so today we're going to be looking at the one away string interview problem. This can be found in page 91 of the book Cracking the Code Interview. So this is the problem right here. It says there are three types of edits that can be performed on strings. So you can insert a character, you can remove a character, or you can replace a character. And then the problem states that given two strings, write a function to check if they are one edit or zero edits away. So we have some examples right here. So we have pale and ple. And this is true because it would only take one edit, which is the deletion of the a. So this is the remove a character to transform pale into ple. Then we have the next example, which is pales. And this is also true because it would only take one edit, which is the insertion of this s character right here that would the deletion, of this s character that would convert pales into pale. Then we have pale and bale. And this is also true because it would take one edit, which is a replacement of this p character into b to convert from pale to bale. And finally, we have pale and bake, and this is false because we would need two edits to do this. We would need to have a replacement of the p into b, and we would also need to have a replacement of the l into a k. So this would count as two edits. Therefore, it's not one or zero edits away. So this would return false. So in terms of a solution, so if we were going to look at a brute force solution here, again, I'm not going to implement this one because it would be really bad, but it would basically be generate all possible strings. So if we had string s1 and then string s2 as our inputs, so if they were, for example, s1 would be pale, s2 would be ple. So what we would do is we would say generate all possible versions of s1 with one edit applied. So what we would do is we would basically generate every possible string that s1 can produce if we do one edit. So we'd start off with maybe replacement, so we'd go through the letters A to Z here, try replacing those, and then we try doing the replacements here and so on, and then we do insertions, deletions. And then what the second one would be compare these they're not really permutations, but I'd say versions to s2 if match return true. Else return false. So again, this is not a very good solution, but it will eventually work. It's guaranteed to work because we've looked at all possible combinations. So this is our brute force solution. I'm not even going to consider the order of complexity. It's going to be absolutely huge. This part one right here is going to be huge. And even this is also going to be huge as well, to go through all of these combinations and to go through all of the characters. So yeah, I don't think this is the one that we're going to do. So what I want to do now is just think about what this problem means, because it's clearly not necessary to generate all possible versions, really. In our best conceivable runtime here, we'd be looking at going through each character of the string. So that would be something like an order S runtime, where S is the length of the string. So we want to look at something close to that. So, so if we think about the problem, one property that we can use to determine for sure that it wouldn't be one edit away is to look at the length. So we can do some, I guess, elimination here. So if we think about it, if we look at all of these strings, their lengths are fairly similar. The only difference is they can be, so string S2 can be either one letter shorter than S1 or one letter greater than S1 or equal to the length. So if S1 dot length and S2 dot length have a difference, so if they have a difference greater than 1, then we can immediately return false. And this would save us from having to go through the algorithm for strings that are clearly not going to work. So if we had something like, so if we had pear, for example, like this, PEAR, and we had, I don't know, pineapple, we can see that they have way too many characters different, so it's not possible to do that in one edit. Another thing we can do is, this isn't really about elimination, this is more like notes. So another thing that we can do is we can look at the number of characters, and if the number of characters are the same, so if the length is the same, then we know that whatever edit that we're going to do, it's going to have to be a replacement, because an insertion or a deletion would change the length of the string. So if s1 dot length and s2 dot length are equal, then replacement operation needed. Another thing that we can think about is if the lengths are different, what would we be doing? So for example, here S1 has a length of 4 and S2 has a length of 3. So to get from S1 to S2, we know that we would need to remove a character. So another thing that we can say is if S1 dot length is greater than S2 dot length, and this is only greater by 1, by the way. Here we already exclude, if we already eliminate the ones that won't work, and then we need a delete operation, so remove character operation. And finally, if we look at the opposite of that, so if PLE was S1, PALE was S2, we know that we need to insert a character to get from this to this. So if S2 dot length greater than S1 dot length, then addition or insertion. So insert character operation needed. So that's a few things that we can think about. So I'm just gonna call this observations. So I'm just gonna note this down as well, because we're gonna be using these rules to develop our algorithm. Okay, so now what we're going to do is develop our optimal algorithm using these observations. So I'm gonna give like quick outline of the algorithm, and then I'm gonna explain the operations using a manual example. So the algorithm is going to be returning a Boolean, and it's gonna have the same name as the problem. So the problem is one away, so it's gonna be called one away, and it's gonna take two strings, a string s1 and then string s2. And the first thing that we're going to do is we're going to check if s1 and s2 have this difference of length of greater than 1, and in that case we're going to return false. So So what we can do here is say we can say if abs. So abs just means ignore the sign. S1 dot length take away S2 dot length is greater than 1. And here we just want to return false. Because like we said before, if the difference is, if it has a length of greater than 1, we can't do it in one operation. Then what we can do is if S1 dot length is equal to S2 dot length, then what we want to do here is we want to do a replace operation. And then we have else. So this means that the lengths are not equal and the difference is not greater than 1. So which means there's a difference of 1 in the number of characters. We want to do an insert / remove operation. So let's just think about it. So we're going to start off with the this bit right here. So if we had the strings let's say apple and pineapple, we can see that the difference is very, very high. So we wouldn't return we would just return false there because they have a length difference of greater than 1. So next thing we're going to do is look at the algorithm for replacement. So for example, if we had S1 is equal to the string let's say blade, and S2 is equal to the string blaze, this is how our algorithm is going to work. So we're going to have a flag, a Boolean flag, to say that whether we have used our edit or not, because we're allowed one edit. And what we're going to do is we're just going to iterate through each of the characters. So we'll first look at index 0. So we're at B. We check if S1 0 and S2 0 match. It does. So then we move on to the next one. So then we're at L, the L's match. So we move on to the next index. The A's match. So we move on to the next index. And here we check the at index 0, 1, 2, 3. At index 3, we can see that they don't match. So what we do here is we set our edited flag to be true. We set this to true. So we've used up our edit. And then we'll just continue on to the next character. And bear in mind that if we find a character that has a difference, if edited is already set to true, which means we used up our edit, we want to return false here. But since we haven't used an edit yet, we can set edit to true and then move to the next character. Then we get to here and the E's match. And once we get to the end of the string, we can do our return. So on a different example, so if we had, let's say, S1 was equal to the string taste, that should be S1. S2 was equal to the string taser. So we'd first look at this character, a T's match, A and A, that's fine, S and S, that's fine. Here we have the T and E that doesn't match, so we set our editor to true. And it wasn't already true, so that's fine. And then we move to the next character, and the E and the R don't match. We check our edited. We can see that we've already used our edit, so we're going to be returning false here. So this is how the replacement operation works, I guess. So I'm just going to note these down, so just so I don't lose it later. Okay, so that's how a replacement would work. So the next thing we need to think about is insertion and deletion. And if we think about it, really, they're actually the same thing because, for example, let's say if S1 and S1 was one character greater than S2, uh, this we could, to do this in one edit, what we could do is we could do a removal of a character from S1 to get it to match with S2. But the same way around, we can also do an insertion of a character in S2 and get it to match S1. So we actually only need to do either an insert or remove operation. We can just operate differently based on which string it is. So this is the simpler way of doing it. So what we do is we'd have two strings, so we keep track of, so we'd have string short and string long. So whichever string is longer goes into long, whichever string is shorter goes into short. And we have two choices, so we can do an insertion operation on short, or we can do a remove on long. So we can do either one of these. You'll see how this works shortly. So let's go with an example. So we have S1, and this is going to be equal to, let's say, desert. Or actually, yeah, let's make S1 longer. So we have S1 is equal to dessert. So this means like uh, the food you eat after a main meal, I guess. So dessert, like cakes, ice cream, stuff like that. So that's with two S's. So this is S1. And then we have S2, which is equal to desert, like the dry region, I guess, with full of sand, like this. So these are the two words. So the first thing we do is we assign short and long. So if we look here, S1 has more characters than S2, so this would be assigned long. This would be assigned short. So we just set the characters like this. So so what we can do is we can just rewrite this just for clarity. So short, long. So we have, so short is D, E, S, E, R, T, and then long is D, E, S, S, E, R, T. And again, we're going to be using an edited boolean here, so we have edited that we keep track of. And by default, it's going to be false. So what we also have is we're going to have two pointers or index pointers. We're going to have SP here and then LP here. And we're going to start them both off at index 0. So at each index, what we do is we check if the character at SP on short matches the character at LP on long. And here we can see that the D and D match. So then what we do is we move SP along by 1 and we move LP along by 1. Then again, we can see that these two E's match. So again, we move both pointers along by 1. Remember, these pointers, SP will point to string short and LP will point to string long. Again, the S's match, so we move here. So here we can see that the E and the S don't match. So what we can do is we first check if we've already performed an edit, and edited hasn't been set to true yet, so we're okay to continue. If edited was true at this point, we would return false because we would need to do another edit here since these don't match. And then, like I said, we have a choice here. We can either do an insertion on short or a removal on long. And I'm just going to go with an insertion on short because it's way quicker. And we don't actually need to edit our strings here. All we need to do is know that if we were to remove this E character to be synced up with the for SP to be synced up with LP, we would simply just move SP to the right by 1. So SP would go here. No, sorry. The other way around, I mean. For SP and LP to be synced up, we would move LP or long pointer to the right by 1. So LP would move here, SP would stay where it is. And we would also set our edited boolean to be true. Then what we do is we again continue, we compare the characters at SP and LP on short and long respectively. We can see that this E and E match. Then we move both pointers along by one. R and the R match, that's fine. So then again, we move both pointers by one, and the T and the T match. And once we get to the end of the string, we know that we can return true because we've only used up one edit. Now, if there's a second character to change here, when we get to a mismatch, we check the edited boolean. We would see that edited is set to true already, so we would need a second edit, so we return false. So I guess this is the ins/remove operation. That's a terrible line. So I'm just gonna make a note of this as well. So yeah, these are the two strategies that we're going to be using. And if you observe them both, we can see that we only make one pass through the string. So this we would get an order n solution of sorts here. So yeah, let's I guess we can start coding this. So if I open my text editor here, so we're gonna have function. I keep forgetting what language this is. So const one away, and it's gonna take in s1, which is a string, s2, which is a string, and it's going to return a boolean. So the first thing that we're going to be doing is just getting the length of the string. So const s1, I'll just call it s1l, which is the length of s1 equals s1. So these lengths will be numbers. So this is s1 dot length, and then const s2l. And the reason I'm just moving these into variables is because if we observe the code here, we can see that we access the length more than one time. So it makes sense to just copy it to a variable rather than I guess it's still instant to calculate the string, but whatever. So s2 dot length, and this won't use up any. Well, it will use up storage, but it'll be constant storage, so it's fine. So then what we're going to be doing is we're going to be checking if the length of the string have a difference of greater than 1, and we can return false. So if and the way we do an absolute is math.abs, and we do s1l take away s2l. Again, it's going to be the other way around. It's greater than 1, then we want to return false here. So that's this bit done right now. So the next thing we want to do is we want to code our replace operation. So, and if we noticed for both the replacement and the insertion, we needed to have that edited flag. So we can just declare it here. So we can say it wouldn't be a const because we're going to be updating it. So it would be let edited, and it's going to be a boolean, and we're going to set that to false by default. So then we're going to be doing the length check again. So if s1l is equal to s2l, so this means that we're going to be doing a replacement operation. So for the replacement operation, if we just refresh ourselves, we can see, let me pin this one actually. So for replacement, we can see that we just basically go through, since they're the same length, we go through each of the characters. If they're different, check if edited is already true. If it is, then return false. Otherwise, set edited to true. And if we reach the end of the string, then return true. So we're going to have a for loop here, and we're going to have let I, which is a number, and we're going to start this off at index 0. We're going to continue until I is less than S1L, but we can also use S2L since they're the same length, and we're going to increase I by 1. And what we're doing here is if S1I, so if the character at index I on S1 is not equal to the character at I in S2, then if edited is true. So if we've already used it by edit, we know we can't have a second edit, so we want to do return false here. Otherwise, we want to set edited to true. So I'm just going to comment this. So already edited, already used to edit. So yeah, so we set edited to true. We'll return true at the very end. We'll do the insertion / removal next. So now we're gonna have an else. So we're gonna be creating our short and long strings. So we're gonna have const short, which is a string, and this is gonna be equal to if S1 has, so if the length of S1 is less than the length of S2, by the way, this else statement means that they have a length difference of 1 because we've gone through the other scenarios here. So if S1 has a smaller length than S2, then we want to set the short to be S1. Otherwise, we want to set it to be equal to S2. There should be a question mark. This is just a shortened if statement. So if S1 has a shorter length, set short to S1, otherwise set short to S2. Then we're going to have our string long, so long string. And what we're going to be doing here is we can either check the lengths or we can just check which one short is. So we can do, we'll just use the length. So if S1L is greater than S2L, then set this to S1. Oops. Otherwise S2. So if S1 has a longer length than S2, then long should be S1. Otherwise, long should be S2. We could have also done another check here saying that if S2 was equal to short, then S1 is long. Otherwise, S2 is long. We also need our 2 pointers. So we have let SP, which is our short pointer, and that's going to be at index 0. Both of these pointers start at index 0, remember. So we have SP and LP. And we're going to set them both to 0. So we want this, we want to be iterating through all the characters, and I guess that happens when we get to the end when SP or LP are at the end or at the length index. So what we want to do is we want to say while let's go with LP is less than s then short s then long dot length. So this just means run until the LP reaches the final index of long. And so what we want to do here is we want to say if SP and then we want to do if short SP is not equal to long LP. So if the character at SP on string short is not equal to the character at LP on string long, what we want to do is we want to say if we've already edited it, so if edited equals true, return false, because we're not allowed to do more than one edit. Otherwise, we want to set edited to be true. So this is very similar to what we have here. And then what we said is we need to move the long pointer along by 1. So for example, when we were here, these didn't match, so we set edited to true, and then we moved this along by 1 so that the pointers are synced up again, I guess, by characters. So we want to do LP equals LP plus 1. So we move this pointer along by 1. Yeah, otherwise, or we can just leave it. Yeah, else, no. We would need to do this anyway. So at the end of each iteration, we also need to move SP and LP by 1. So SP equals SP plus 1, LP equals LP plus 1. So again, remember in each iteration, if we still move both indexes along by 1. So for example, here we do we set the editor to true. We move LP to this E right here. So the SP is already here. Then we move both of them along by 1 to get to the next character. So we move this to R and we move this one to R. So again, we return false here. And finally, at the end, so if we haven't encountered 2 edits at any point, and we go through either this one or this one, then at the end, what we want to do is we just want to return true. They are 1 edit away. So yeah, this is the coded solution right there. One thing I forgot to do actually is go through the order of complexity. So I'm just going to do that quickly. So let's go through time complexity first. So this bit, string length is constant to access, and we're just comparing it to a number. So that's order 1. The replace operation is going to be order S1 or order S2, depending on which way we go, but they're equal. So it's basically order S, where S is the same length. Otherwise, this operation right here is also order S1 and order S2, but S1 and S2 have very similar lengths. They're only a difference of 1 away, so this is also order S. So the time complexity is order S here. If we think about the space complexity, so here we're not doing anything. So this is order 1 here. We're not storing any information here other than a Boolean, which is constant. So this is also order 1. Here, we're going to need order S1 plus order S2 space because we need to have our short and long strings. So this is just going to be order S space complexity, I guess. So in total, the space complexity in this case is order S. If we use a duplicate string, that is. But if you think about it, in a lot of programming languages like Java, you can just set a reference called long or short, and you can just point it to the original string. So if we think, so if using pointers, this would actually just be order 1 because we wouldn't need any extra space. We would just set short to point to S2 here, and we would just set long to point to this. So we wouldn't actually need to copy out the characters. In TypeScript, of course, we can't really do that. So we have to do this. We have to use a separate string. So I guess we've achieved the optimum space complexity, and we've also achieved the optimum time complexity. So yeah, this is the definitely the optimal solution that we can have. Yeah, I forgot to go through that before, so I'm just gonna just make a note of this as well. Let's get a bit more in. Yeah, that's the time and the space complexity. Okay, so we have our coded solution right here. So I guess all that's left to do now is to check this. So we can do console.log 1 away, and let's see what let's use the examples to start with. So we have pale and the PLE. So let's try it with that. So pale PLE like this. I'm not expecting this to work first time, but we'll see. it might be surprised. So TS node demo. So for pale and PLE, we can see that it returns true like it's supposed to. Now let's try pales and pale. So pales, pale, and it returns true. That's correct. Pale and bale. So pale and bale. Yeah. And if we had pales and bale, we can see that we need an insertion and a deletion and a replacement. So this should return false now. Yeah. And then finally, let's do this one. So pale and bake. So this is where it needs two replacement operations for the lengths are the same. You can see that we get false. Let's try blade and blaze. And this should be true. Yep. Let's try taste and taser. And yep, that's false because we would need two edits. And finally, let's try the example. So we have desert, or desert, sorry, and desert. And we can see that it returns true. So our solution does seem to be working. So we have coded the optimal solution right there. And again, it takes order, space, time complexity, and realistically on a good programming language, order one time complexity. So this right here is my optimal solution to the one-away problem. If you have a better solution or something different, I'd love to see it in the comments. Yeah, so yeah, thank you for watching.